The question is, two shots are projected from a gun at the top of the hill with the same velocity u at an angle of projection alpha and beta respectively. If the shots strike the horizontal ground through the foot of the hill at the same point, show that the height h of the hill above the plane is given by this equation, that is h is equal to 2u square multiplied by 1 minus tan alpha tan beta divided by g multiplied by tan alpha plus tan beta whole square. So this is a question. So in this case, so basic, it means that there is a hill of height h and two shots are fired with the angle of alpha, another one of angle beta, and let us suppose they strike at the same point here. So let's say this is origin and the shots are fired from point A and it strikes the horizontal plane at point B, which is at the level of foot of the hill. So we assume that let this distance between O and B is given by, let us call this as x. So in this case, what we are going to do, we are going to use the equation of the trajectory. So basic equation of the trajectory, equation of trajectory, it is given as y is equal to x tan theta minus g square divided by 2u square cos of theta. Here theta is our angle of projection. So we have two bodies, A and let us say A and B. We have two bodies, let us call them C and D. This is C and body D. So we can say that for C body, we can write this equation of projection as, equation of trajectory as minus h is equal to x tangent of alpha minus gx square divided by 2u square cos of alpha, and for body D we can write this as minus h is equal to x tan beta minus gx square divided by 2u square cos of beta. So let us just call the equation number 1 and equation number 2. So we can equate equation number 1 with equation number 2, equating equation 1 and equation 2, we get x tan alpha minus gx square 2u square cos alpha is equal to x tan beta minus gx square divided by 2u square cos of beta. So we are going to shift x tan beta to left side, so we get x multiplied by tan alpha minus tan beta, and taking this to the right side, we are going to get this as one half gx square divided by u square is equal to, sorry, I missed square here, so I missed the square, in the equation of trajectory. So this can be written as 1 upon cos square alpha minus 1 upon cos square beta. This can be further solved as we can write this as 1.2 gx square u square secant square alpha minus secant square beta, and this will be equal to x, and x cancel out with this square, so we are left with here as tan alpha minus tan beta. So from here we can say that two u square by g, 2u square by g multiply by tangent alpha minus tangent beta is equal to x secant square alpha minus secant square beta. So we can solve our right side as 1 plus tangent square alpha minus 1 plus tangent square beta. We open the bracket, get x 1 plus tan square alpha minus 1 minus tan square beta, 1 cancel out with 1. So we get this as x, this will be a square minus b square, so we can written as tan alpha minus tan beta and tan alpha plus tan beta, and on the left hand side we have 2u square divided by g multiplied by tan alpha minus tan beta. This cancel out with this. So from here we can write that x is equal to 2u square by g multiplied by 1 upon tan alpha plus tan beta. So let this be equation number 3. You already know the equation number 1. So equation number 1, equation 1 is given as minus h is equal to x tan alpha minus 1/2 g x square divided by u square cos square alpha. So in this equation we further can solve this as taking x as common, and solving for minus sign also, we get h is equal to 1/2 g x divided by u square cos square alpha minus tangent of alpha. So in this equation, substituting the value of x, so we are going to get this as 2u square divided by g tangent alpha tangent beta and 1/2 g 2u square multiplied by g tangent alpha plus tangent beta multiplied by 1 upon cos square alpha minus tangent of alpha. So 2 cancel out with 2, g cancel out with g. So we are left with, and u square cancel out with u square. So we are left with 2u square g tangent alpha plus tangent beta divided by 1 upon cos square alpha can be written as secant square alpha divided by tangent alpha plus tangent beta minus tangent alpha. So this can be further solved as 2u square g tangent alpha plus tangent beta. Taking tangent alpha plus tangent beta as LCM, so we get secant square alpha minus tangent square alpha minus tangent beta divided by tangent alpha plus tangent of beta. So secant square alpha minus tangent square alpha is equal to 1. So we can write this as 2u square g tangent alpha plus tangent beta 1 minus tangent of beta divided by tan alpha plus tan beta. We can combine the denominator. This is a plus b into a plus b. So we get 2u square 1 minus tangent of beta divided by g tangent of alpha plus tangent of beta whole square. So we get the value of h is equal to 2u square 1 minus tangent beta divided by g multiplied by tangent alpha plus tangent beta whole square. Thank you.